All right, hello everyone. It's Xander, and welcome to a devlog about Dimensional Engine. This is, I guess, devlog number 2, if you could call the original showcase a devlog. But I do have some very exciting updates to share with you all. I've been working on a little on the renderer, but not too much, but mostly on editor workflow and allowing the editor to be used more efficiently and quicker and easier and more intuitively by users who may want to develop games in Dimensional Engine in the future. So the editor looks a lot different. Uh, Basically, everything's changed other than the hierarchy and the properties panel. So as you can see down at the bottom, we now have a content browser, and on the right we have a materials tab and an asset registry tab, which I will get into more in depth later. So materials aren't necessarily anything new. The renderer has supported materials since even before the original devlog. However, you weren't able to edit them inside of the engine editor. You had to close it down, modify the source code, and restart it. But now it's all configurable, it's all savable. That's a big feature, is that you're able to save levels now, and you're able to save materials and edit them in engine, which allows you to have a lot quicker iteration time on games if you're going to build it, and level designing for those games. So yeah, I guess I'll just talk about this a little bit. It's a very similar scene here to what I had in the first devlog. We just have a few cubes and material balls here, showcasing the power of the renderer. That's not really new from the last time, but here's another model that we can look at. I didn't showcase last time. So I didn't create this model, but it is a very cool, high quality PBR model here, and you can see the material system in action. And that's actually another thing I want to mention, is that the asset management system of this engine has been completely overhauled. Basically everything that the asset manager did before, this new one does 1,000 times better. It allows for serialization and loading, deserialization or loading of scenes and of materials and of anything else in the engine. So I guess I can show that off right now. So we have this scene that you've been seeing the entire time, and if this is new scene. And if I go to new scene 1 and drag that up into the viewport, it'll switch me to another scene with completely different atmosphere and everything. So yeah, it's pretty different from before, and I guess I'll show you some the modifications that I did here. So if I click on this backpack, for instance, currently it has the model of Survival Backpack 2, and that is located here. So it's a dimensional it's a dimensional model that references this source FBX file and has a dimensional material here, which you can modify in here. But essentially, if I want to change the model here, I can very easily. Let's say I want a sword. Here, let me generate a dimensional model from this sword. I can drag that up here and turn it into a sword, and see now it is a sword. It keeps all of its location, and this one was scaled up a bit before, so I guess I can just reset it here, and I have a sword. And I don't know why you'd want to do this, but if I wanted to give this sword the material of the backpack, I could just drag the material into here, and now it has the material of the backpack. And of course the UVs are not lined up, and this material was not made for this sword, so it's gonna look pretty sucky. But there you go. Say you had a material that was just a clear color or base color, then you could throw that up in here. So I'm gonna reset that back to the default. And so another thing is there is a new asset importer. And so this asset importer should be able to support importing FBX models and their model data, their vertice data, and everything into the engine. And if it can, it will attempt to find any textures associated with it and create a new material. For this sword, in this specific example here, the sword is not there's no embedded textures, there's no path to the texture file, so you'd have to create it yourself, and I'll show you the workflow of that currently. Still very early days, but if I go into the sword and see, it did create a new material for it, and you can see that the material is being used here. But if I search for this material in here, you can see that it's just, there's no textures associated with it right now. It's just using the default material. But I can change that by taking the albedo, putting in the albedo, taking normal, put in the normal, roughness, and I don't think this one comes with anything else. Yeah, no, there's no metalness or ambient occlusion, so it's just going to use default. So I'll go ahead and save the scene up here. And so now this is no longer a backpack, this is a sword, and it has a new material. And of course, same as before, we can move around the lights. This is a spotlight, or the point light, and then the spotlight is right here. Another very, very cool thing that was not in the engine before is our customizable HDR maps. Originally in the first devlog, the HDR map, just like everything else, was hard-coded in the thing, but not only that, but it could only support one HDR map at a time. This new engine can support references to multiple at a time and keep multiple in memory just in case you want to switch scenes really fast or switch them out on the fly. So let me show an example of that and go back over into my textures tab in my content browser. And if I just go to the skylight here, taking inspiration from Unreal Engine and having skylights be actual entities in the game. Of course, they don't render anything; they just render a skybox. Okay, so you can see that right now we're using HDR map stars, and there is an LOD. I don't know why it says linear. That's probably a mistake on my part. It should say level of detail or LOD. And we can actually change the level of detail that is being sampled by the skybox. So if you really want the clear skies, you can set it to a really low level of detail. And if you just want it to be kind of a solid color, you can just raise it up. It doesn't change the way models are rendered or sampled. These models and stuff will still sample the same way as they do before, but you could just change the look of the skybox. And potentially in the future, you could have two separate things. You could have a skybox, and you could have an environment map that you want your models to reference. So yeah, they're hot swappable, just like the models and the assets and the textures and everything. So I'll show you that. So if I wanted to take this fire, I'm going to drag it in here, and no scenes currently loaded actually reference this HDR that I'm about to drag in. So it's actually going to pause for a second and load it. And so that's another powerful feature about the new asset manager, is that assets are lazy loaded, which means that yes, my engine can see that all of these assets exist, and that's what the registry is for. But these assets are not loaded in memory. This PNG is not loaded to memory. This PNG is simply just a type, a path, and a handle. But if at any point a model in here referenced a material that referenced this PNG, it would then load this PNG into memory and keep track of it and ensure that it can be used by the engine. So that allows memory to be pretty low throughout the runtime of the game and of the engine. And yeah, I guess I'll show off the saving and loading. So we modified this scene. This is our new scene 1. I'll just go back to new scene and see this, and we can load new scene 1. And I'll save it again, and I'll stop the engine. I'll run it again, and if I drag in new scene 1, it's gonna load the scene, and it's exactly where we left it off. So this is a huge step forward. Previously, it was rough. I had to hard code everything in the engine, and it was much more difficult to create scenes. Oh, another thing, just kind of quality of life thing. If I wanted to copy this, it's still labeled backpack, but it's a sword now. I'll rename it to sword. If I wanted to copy this, I can just click it and press Control D, and now there's another sword, and I can move it out and make a level out of it if I wanted to. So of course you can see this is very similar to how other engines do it. However, the asset manager is slightly unique, and I don't know if I like the way that I do it right now, and I might take inspiration from Unity. So I just downloaded this before I started the video. Right now there's no, it doesn't have any dimensional assets in it. It's just a simple source file and some material files or texture files. But if I right click this, I can click generate model, and it'll generate a dimensional asset for me. And this can be here. I'll just create a new thing. I'll call it gun, because this is a gun model. I'll create a new mesh, and I'll drag this in. Okay, so I just generated this model. I just generated this. This is the, I mean, I just got loaded into memory. My engine has not seen this before. Well, since I deleted the registry. However, it has a texture attached to it, and that was what I was talking about earlier, where it'll do its best to scan the FBX to find materials. Now, this FBX, whoever created this FBX, didn't necessarily put the textures in the right slots. So, but the textures are here. So it was able to find the albedo, but it was not able to find normal metalness and roughness. And that's okay. That's why this material editor's here, and for editing your own custom materials. But for instance, I can take now the roughness, put it in here, take the normal, put it in here, take the metalness, I'll put it in here too. Where's there we go. And I'll save it. And now it's a full material, full model with a full material integrated into the render pipeline. So yeah, if you made it this far, thank you so much. That's the end of really the showcase of what the new capabilities are of the engine. But I do want to go into a little bit of a technical deep dive and explain a little bit how the asset manager works, because it is actually very interesting, and I think will allow iteration further on in the engine to be much faster. Okay, so let's talk about how the asset manager used to work. Asset manager before was a simple, was just a static class, and it had a map. And so this was a map of shaders, and it had a, actually hang on, let me get both of those, yeah, and it had a map of textures and everything. So every asset had its own map here, and it was just a map from a path. So a string was a map of a string to a pointer to memory, and that was it. So this actually has a few downfalls. Actually, it has a lot of downfalls and a lot of things that makes it kind of unnecessary. So for one thing, strings are not really trivially hashed. They of course can be hashed, and you can use them in hash maps and in maps, but they can be slow, especially if you're doing a lot of operations on them. And as you can imagine, an asset manager inside of a game engine that has potentially hundreds of assets, it's gonna be used a lot. So you want to make this is a pretty hot code path, and you want this to be pretty efficient. Okay, so that's one thing that was a problem with it. Another problem is that every time I added new texture types or new asset types, so say now I wanted to add, so this is actually an issue that I came up with that I ran into last time, and so now I have to make a map of environment maps. Or whatever. Okay, so pretty difficult to do, and so on top of going through and writing all of the import code and everything, I also had to go and add this new map here and make sure that I added all the functions for this specific map so that it can take in the correct parameters. Because also to create things in the asset manager, you'd have to call specific functions. This is like asset manager create shader or create texture, so it wasn't just a single function for all. So that is bad. That was bad. That did not work very well, and it did not scale very well. With this new system, I did take some inspiration from other people who have done this before. I read some source code, and I looked at how Unity does it, and I decided to do sort of a mix of these things. And actually, I might switch to a more similar way to Unity later on. However, for now, this is because the current way that I'm doing it actually does have some drawbacks, but that Unity could potentially fix, but it also fixes some things that Unity does. So at any rate, here's how mine works. So now we have this asset manager class, very similar from before, except for now assets actually all have inherit from a parent class, and this parent class, I'm not a huge fan of inheritance usually. And so this is a very, very, very light class, and it only has really one virtual function that is a get asset type that will only be necessarily used in the editor version, so it will not be used in runtime where speed is actually crucial, and it has an asset handle. And this is just a U64. So an unsigned 64-bit integer. Okay, so that is its globally unique ID. And all of these different assets inherit from it. So shaders and textures and models and so on all inherit from this class. Okay, so all of these things have an asset handle. And so now this asset manager class, all this has to do is manage assets based on their handle, which is much better than managing them by their string. So I mean, there's a bunch of functions in here that have to do with creating and managing assets, but that all operations on an asset are done through the asset ID. So every reference in the engine is done through an asset ID, and this is serialized. Okay, all right. So there is a thing called an asset registry, and that is what keeps track of the paths and the types and so forth. Okay, so this asset registry, what does it do? Okay, so the asset registry, all this does is keep a giant list of everything. So we got a handle, so that's the U64 ID. We got type, so that would be things like texture. Is it a texture? Is it a model? Is it whatever? Okay, but there's also its path, and this is relative to assets folder. Okay, so that is what the asset registry keeps track of, and that's just for everything. So it's basically just a giant map of asset handle to type and path, and so just metadata. Basically just keeps track of asset metadata. Handle, type, path, can be other things in the future. Currently, that's all it is. Okay, so there's this giant map of handle to type to path, and type and path. All right, so of course, these handles are randomly generated on whenever you create a new asset. So how do you manage references on loading of a scene? So there's also a registry serializer, and all that does is take all of this information and write it to disk. Okay, so all right. So now we have saved all of the asset handles and their path and their type to disk. So next time you load the engine and you load a project, currently there's no such thing as projects, but bear with me, just pretend it's just one giant project. You open the engine, it loads this registry. So now the engine is aware of asset IDs, what path that ID goes to, and what type of asset it is. So now that is saved between sessions. Okay, so what can we do from there? All right, so we have this asset manager now that is aware of all of this asset metadata information. Okay, so you can get it, you can register. So I mean, this has a lot of functions. Just a few of them is you can get an asset, you can register an asset, you can check if it's loaded, you can check if it is registered, and or whatever. And you can do all of this regardless of what kind of asset it is. All you need is asset ID. If you send the asset ID to get asset, it can know what type of asset that is due to the asset registry. The asset registry knows what type of asset it is, so it can cast it to that kind of asset and return it. So when you need to render a model, say we now have the renderer here. Okay, we need to render this model. So the scene keeps track of different entities, and say there's a mesh, there's an entity in there with a mesh component. Okay, there's a mesh component. All right, so here's the scene. Here's okay, well, it's not really a render anymore, but it's a scene, has a mesh component, and this has a model ID. This model ID we can now say, okay, asset manager, I want to get the model with this model ID. It'll be like, okay, dude, that is registered and can be loaded. So it checks if it's registered. If it's registered in the asset registry, that's a valid model ID. Then it'll retrieve it. If it's loaded, it'll return it. If it's not loaded, it'll load it and then return it. Okay, so now here we have a valid model. Then our renderer can be like, okay, cool. Now we have a model in memory. Let's take that model and render it. Very, very simple. We don't have to do any. Manipulations of strings. We don't have to send a string to the file system and load it manually. It was all done by the asset manager and all automatic. Very, very nice. And so basically everything in here is an asset. Let me try to think about what else I can say. I guess let's okay, so now we know what the asset manager is and what the registry is and how it works. Let's hop in and look at some actual code. Doing some stuff with Vulkan, but let's hop into and look at some actual and see what it looks like. Okay, so all right, let's get assets. Okay, so this is the assets folder that we saw in Engine earlier, and so here is the asset registry I was speaking about. All right, you can see there's a many assets in here, and each of them have their own handle and a source path and the type. And so that's literally all this is. It's just a serialization of all the assets that the engine knows about, and that can be per project. Okay, so how are things referenced? Because I think this is pretty easy to wrap your head around. But how are things referenced? So say we have something with a mesh component, and we do inside of both scenes. We can look at what the scene actually looks like on disk. Okay, so we have this scene called Untitled Dimension. Eventually scenes will be called dimensions and dimensional, but currently names won't have anything to do with it. Okay, so each entity has its own handle. Sure, that's been there before. And so then we have all of the components that are associated with this entity. Okay, so this gun has a model handle. So this is the asset handle of this model, and it is this. All right, so let's take a look at what that is. Let's open the registry again. Control F, find it. Oh, cool. So that it does exist, and it is in fact the gun model. But if you notice, this is not an FBX file. This is not an object file. This is not a 3D model file. So what is this? This is a dimensional model. And dimensional model is very simple. It is simply just a handle to a source file. And this would, if we copy this, it'll take us to the FBX file. Okay, so why do we do that? Right now, there's no reason to do it. However, in the future, there could be certain import settings that we want to keep track of for different versions of a certain model. Now, one thing that Unreal Engine does that I don't personally like, and I kind of took inspiration of to try to fix, is when you import an FBX file, you have one import setting for that, and it will and you can't change that. So you have an FBX file, you put it in, and boom, you have all this import information. You might want to import it differently next time. You'd have to re-import it completely and have two different versions of that FBX file. this gets around that by having a dimensional model that references the source and could have different import settings. So say in the future, maybe we have we want to import the rig. We can say the rig true or whatever. I haven't done much with animation yet. Or say we want to only use certain submeshes. We could have an array say, okay, I want to use submesh 0, 3, and 4 if we had that. Or whatever. There's, I mean, many things you could possibly want to change about an import settings on various models. So that's why we do that, and yeah. Okay, let's check out the registry again, because there is another type of asset that is not a standardized sort of thing. So we have this asset here, which is of type material, and it links to new mat dot dimensional material. Let's see what that is. This isn't the same thing, but it is a material. Okay, here's the material for that model I was just showing you. And you can notice that these images are just asset handles like we were talking about before. And so if we copy this and go to the registry and find it, it is just an image, a TGA image for the albedo file. And so this makes it super easy to just switch out references and keep them saved. We don't have to serialize the path. We don't have to serialize anything about the actual memory layout. We don't have to do anything. All we have to do is change this number. If we change this number and the new number is a valid ID of another image inside the registry, it'll just render that. It'll just keep track of that. I don't have to do anything about it. And so that's sort of the power of this new asset management system, and it allows you to ensure that you have saves across sessions and keep track efficiently of your assets. And of course, right now there is no concept of unloading assets. I've not needed that yet. Of course, I will need that eventually. And so the way I plan to get around that is I will just, inside of the asset manager, I'll keep track of the number of references. Oh, that's tiny. So of every asset, I'll just keep track of the number of references. And say on a particular frame, the references of some model, some model, say gun model. So tiny. Say the references of gun model are now equal to 0, and they have been for, say, I don't know, 200 frames. Then I could be like, okay, the engine hasn't needed this model for a while. Potentially it's not in the scene anymore. Potentially it was in a room far back there, and I don't need to render it anymore. I can say, okay, asset manager, now that we don't need this gun model, just remove it from memory. Don't delete it out of the registry. The asset manager still knows it exists. It's just not in memory anymore. So that means that in the future we have room here for new models, new textures, new environment maps, whatever, and we can unload and reload assets on the fly. Now, of course, the actual implementation of this can be as complex as I want. Maybe I'll implement some sort of caching system or LRU, like least recently used cache, something like that. But essentially, keep track of the number of references. If it's not referenced anymore for a while, unload it, allow room for a new asset to be loaded. Okay, so that's really it on the updates so far. Now I do want to take a little bit of time to talk about what I plan on doing in the future. So let's see, let's do this. If you keep a look at the GitHub, I'm going to try to put a roadmap there. But essentially, there's a few things that I want to do soon. Let's do Excel. Okay. So the next things I want to do. All right, let's see. The renderer needs a rewrite. Okay, so let's. I need to rewrite the renderer. Currently, it is not written in a way that's super scalable. It works, of course. You can see that it works, but I would like to update it to use uniform buffers, support more lights. I would like to update with some new information I've learned from PBR techniques from Epic Games paper. I would like to also currently I need to add a scene renderer. Currently my main renderer, my 3D renderer, kind of acts as a scene renderer and a renderer, render API abstraction. So I need to sort of separate those two and have a base 3D renderer that just deals with data, and have a scene renderer that deals with scenes, and then that can sort of be the glue between scene and renderer. Right now they're sort of combined, and that's not good. It makes it very hard to iterate, makes it hard to do updates, yada yada yada. So that's what I need to do there with the renderer. Okay, update renderer. Also, I would like to start working on runtime. Right now there's no runtime. Right now it is just an editor. I mean, so there is a core library that deals with everything, and then there's an exe that links to it that is the editor. So really you could just make a copy of the editor and remove all of the editor tools, and it would essentially be a runtime. But there is no runtime. There's no separate exe for running projects without the editor. I'd like to get that done. I'd like to add physics and allow that to work. And also, runtime requires a different kind of asset manager. In the runtime, you don't want to be dealing with strings. You don't want to be dealing with files. You don't want to be dealing with reading in YAML files. So I would like to write a new asset manager for the runtime that deals in just straight binary, and so I can pack all of the assets into binary format for quick loading, really fast during runtime. Okay, so I want to work on runtime, runtime app, runtime asset management, all of the above. Okay, that's going to be a huge task. So that is probably not going to be done for a while. Probably the most likely next thing is the renderer rewrite. After that, I mean, add physics and runtime. So I'm probably thinking about using Jolt physics or NVIDIA PhysX. If you have experience with either of these and you have a recommendation, let me know, and I will do my best to look into them a little bit more. Okay, but aside from Dimensional Engine, I also, of course, a full-time student. So I need to be focusing a little bit more on school, and also I would like to start focusing more on learning Vulkan. Vulkan is a much more modern graphics API than OpenGL. Currently we use OpenGL. OpenGL does not play friendly with multiple threads. I'd like to multi-thread this and have a rendered thread, but Vulkan is also very difficult, and I don't have much experience with it. So I may take some time from this project to go build some smaller projects in Vulkan and see if I can come back and rewrite the renderer again in Vulkan. Of course, I am going to rewrite the renderer in OpenGL first, because I just want to make sure that I do fully understand OpenGL to the extent I like to, and then on the side I'll be learning Vulkan, and eventually I'll come back and rewrite the renderer in Vulkan and allow it to run much faster. Vulkan has a lot of performance updates, performance gains over OpenGL, but that also means that it's very, very verbose, and most of the work goes to the developer as opposed to the driver. At any rate, I'm going to be learning Vulkan on the side, so I might be taking some time away from Dimensional Engine. However, I do think there's been a lot of progress made, and I will be still working on this, and I will not have lose confidence and motivation in this, because I have been having a great time learning how game engines work. Okay, so that's really it. I think I got everything. Keep an eye out on the GitHub, and I will be posting a roadmap most likely next week or the week after. So, or maybe, yeah, probably next week or the week after. So, keep an eye on that. All right, thank you everyone so much for watching. It's been a pleasure, and I hope you learned something. Thanks everyone.